our vision of the future is being able to recharge any vehicle, whether it's a semi freight truck, or a small passenger vehicle in just 5 or 10 minutes. And one reason that we're so bullish on that is because of solid state batteries and other battery improvements. But our technology is one of the few that actually allow that like remove that grid capacity problem, which as the charging speed becomes more closer and closer to something like gasoline, refueling in 5 or 10 minutes, it places a larger and larger demand on the grid and the available real estate. And those are the two problems we in particular solve.
Hello, everyone, and welcome back to another episode of Clean Tech is the Podcast. This is our 30th episode. Kind of hard to believe that we're already this far. If you listened to last week's discussion with Tim Barrett of Gridware, I would love to hear your thoughts on how the conversation went, what your thoughts were in general in the IoT space and the grid and transmission space. If you have not listened to it, there will be a link in the description for you to go listen to that as well. Very interesting conversation. And then before we get into today's episode details, wanted to obviously thank our sponsors, NextWave Partners, for sponsoring and making this podcast possible. NextWave are experts in the talent acquisition and recruitment across the climate tech, renewables, and ESG spaces globally. So if your team is growing or you want to make a change in your own career, please do consider reaching out to NextWave. You can do that at next-wavepartners.com or reach out to one of their consultants directly via their LinkedIn page. So with that, let's get into today's conversation with Josh Keister. He's the president at Resilient Power. As mentioned at the end of last week's show, Resilient Power was just recently funded by one of our previous guests, Craig Lawrence, on the episode when we talked about his VC firm, Energy Transition Ventures. So really, really interesting conversation today. I think that this technology is going to be very, very changing for the way EV charging is deployed and just looked at in the future, as their technology is able to reduce the size of charging stations, increase the speed of charging, and the speed of installation. So a couple very interesting factors here. Some patented technology they have that, kind of like most innovation, was stumbled on accidentally. So very interesting conversation with Josh today. We hope you enjoy it as much as we did. And with that, let's get into the show. All right, Josh, welcome to the podcast. How are you doing today?
Great. Thanks so much for having me, Silas. Happy to be here.
Yeah, I'm super excited for this conversation. Have obviously heard some interesting things about what you guys are doing at Resilient Power. So could you maybe just introduce yourself initially to the audience, people who aren't aware of what you guys are doing and what you've done?
Yeah, I'm one of the co-founders at Resilient Power, and we recently announced a financing round close with Amazon and Energy Transition Ventures, and we're a EV charging company that produces basically a prefabricated EV charging station in a box that's about 1/10 the size and installs in about 1/10 of the time.
Okay, got it. So could you maybe talk to us about, I'm curious to hear, how did you guys end up in the space of, designing this system in the first place? How did you get down this route? Like, what was the impetus for your journey?
Yeah, that's a great question. We started as part of the U.S. Department of Energy, and through that work so far, we've gotten about 7 U.S. patents. We're a tech-heavy team, and when the Department of Energy approached us, they were actually asking us to work on something more related to a national security supply chain problem, which was a story and a National Security Council report that was leaked in the Wall Street Journal maybe 10 or so years ago, that said if as few as 9 transformers in the U.S., large power transformers for the grid, were damaged with something as simple as a rifle from Walmart, that it could knock out 2/3 of the grid for an extended period of time, and that's 2/3 of the U.S. For months at a time. And part of that concern is because the U.S. Only has the manufacturing capability to manufacture about 2 of those transformers a year. And so the Department of Energy came to us and said, "Hey, if you didn't have any factories and you wanted to, start replacing a large amount of grid infrastructure in a short amount of time, how would you do it? At either a with low capital investment or with just the available materials at factories in the U.S." And through that research, we stumbled onto this way to shrink the size and cost of EV infrastructure, and that's when we really started to push the company hard to commercialize this new technology.
Interesting. So kind of not necessarily setting out on the path, but ended up in this direction. Maybe could you maybe talk a little bit about how that transition went from, obviously seeking to solve a problem and then finding a different problem that you've solved and then kind of being able to, especially how you were engaged with Department of Energy, how you're able to then switch your focus to the research and development and perfecting that product.
Yeah, I mean, part of the transition, while we were always interested in the EV charging application, we've gotten a number of acquisition offers so far, and some of those have been, outside of the EV charging space. And it's because our patent portfolio has a wide array of applications. So while we were aware of EV charging, I would say with the announcements of Volkswagen and GM and Ford and really everyone committing to basically fully transitioning to electric vehicles, that amount of inertia over the last say 2 years has really removed a lot of the market risk and market uncertainty around electric vehicles. We have Tesla to thank for that, and now Rivian, who is poised to grow very quickly as well. And with all those technology improvements, like in the battery area and other economies of scale improvements, pushing down prices, there's so much momentum. I mean, if you look even outside of California and New York, that in 3 out of 4 cities in the U.S., it's already a lower cost to operate, especially for things like delivery vans or last mile delivery.
Mhm.
In urban areas, it's already the lowest cost in the majority of cities to go electric. And so that's something that's, we would say, materially changed over the last 5 or 6 years. And with that, it just happens that EV charging is basically the easiest application for our technology, but it's the largest at about, I think it's estimated to reach $145 billion in market size by 2028, and a $2 trillion a year value by 2040 is what Accenture estimates. And that's really just for the energy sales to electric vehicles. So it's playing in some very large markets. So that's why it's our highest priority and first application of this power electronics platform we've developed.
Interesting. So, and just to clarify, you said that's only on the energy sales. That's not even calculating into effect all of the infrastructure builds and all the technology itself.
Yeah, so the $2 trillion a year is from the Accenture e-mobility report, and that's, I think, by 2040 in Europe and North America alone. And 1.7 trillion of that is just the, kilowatt hours
Mm.
sold to charge all the electric vehicles.
Interesting. Okay, got it. So basically, massive growth happening here. That's interesting. Okay. Very cool. Well, I guess, one thing that I have quite low kind of familiarity with the, I guess you could say, development process for these charging stations. Could you maybe walk us through? I'd be keen to first understand what you understand to be the traditional method of going and developing these EV charging stations, and then kind of in contrast, what it would look like to work with your technology to do so.
Absolutely. Yeah, the status quo is about 10 or 12 times, larger than us, that has an extended permitting and planning and engineering process, well over 6 months. In some locations, you actually need a different permit for each of the 4 or 5 pieces of equipment that typically goes into a charging station. And there's miles of conduit and wire buried under concrete, uh, to connect all of the, power conversion and power conditioning equipment that's needed to supply power to all of the EV dispensers. As an example, in downtown Boston, we had a customer, come to us where the local utility was proposing taking up 25 parking spaces of their parking deck to enhance or build up more power capacity. There are some government entities that want to electrify their fleet, and a few other large customers that they have. And our solution, on the other hand, can fit in less than one parking space. And so it's just a night and day difference. And in addition to, I mean, if you can think of installing 25 parking spaces worth of equipment, that's actually going to be weeks, if not months, of on-site construction. And so with the supply chain challenges now, you actually have to coordinate, 4 or 5 different companies that are supplying all of these different materials to arrive at the job site at the same time. And then as another example, some friends of ours from Tesla, they were responsible for building hundreds of supercharging stations all over North America. In a large part of the country, like, the Northeast and Canada, the ground is actually frozen. You can't trench during a large part of the year. And so we eliminate, 90% of the trenching and, underground work as well, which is, again, fewer permits, fewer, a smaller crew. And so, companies like Amazon and others that have mandates to install a large amount of this equipment, they recognize that with our system that's basically prefabricated at a factory, in climate controlled and highly automated factory setting, you're not only getting efficiency improvements and that the labor is just more efficient, it's also higher quality because it doesn't take a rocket scientist to figure out that if it's 20 below zero outside and you're, working with tools out of your truck or, other kind of construction like settings, you're just not going to be doing your best work out in the field. And so by pre-assembling all of that in a factory, you can actually install that same 25 parking spaces worth of equipment in 1 or 2 days just by basically lowering our system off of a truck that was all pre-assembled at a factory.
Mhm. Are there any upgrades that still need to be made for companies trying to put these charging stations in? I know a lot of people I have spoken with have mentioned that there's massive upgrade costs for the transformers or whatnot. So I'm just kind of curious if you could walk us through maybe a little bit more, but not too technically, into how that works and what preparation might need to be done before your units would arrive on site.
Yeah, you're absolutely right that uh, the transformer is one of the most expensive parts to upgrade, and that's not only due to the material costs, but the civil works. That equipment is typically very heavy and large, and so in many, especially urban locations, they don't have room to site it. So you're talking about like building,
Mm,
breaking down walls, or uh, you know, putting it in a vault underground, all of which is quite expensive. And so with our system, it does eliminate 90% of the upgrade costs for things like breaker panels and transformers. There was a Goldman Sachs report that estimated nearly $6 trillion worth of investment is needed to fully electrify, and I think that was in Bloomberg. And they pointed out that over half of that is actually due to the grid upgrade side, and due to power inadequacies, and because
mhm,
most facilities were actually built and were not planned to have a large amount of EV charging infrastructure. So it's rare to find a facility that actually has enough extra capacity. And so we eliminate 90% of those costs. And the only thing that we don't eliminate all of is if the power line, either be it an underground cable or overhead power line from the utility, if that line doesn't have enough capacity, then there's only a we help alleviate that to a lesser extent. But yeah, with our equipment, you can avoid up to, depending on the utility, up to 3 years of lead time, either from a procurement and installation time. So there's a lot of utility effort that we also make unnecessary. So that's making everyone's job easier.
Interesting. So the only real restriction is essentially what the capacity of the power line going to that specific building is, for example.
That's right. Or the power line that is, nearby,
Mhm.
kind of in the neighborhood.
Got it. Okay. Interesting. So maybe one thing to go a little bit deeper into the technology, again, not super specific technical terms, but could you explain, kind of like you're explaining to a child, how what you're doing is working essentially?
Sure, it's kind of like, you could compare it to, in one of the ways that we're such a small size is that it's kind of like a cell phone or multifunction printer, and that if you embed a lot of different functions into a single device, that's one way that you can become more efficient, either in space or costs. And we outlined that in a paper that we co-authored for the US Department of Energy called the Solid State Power Substation Roadmap. And that term was coined to um, really give the idea of replacing many different devices with a single one. You could also compare it to kind of like a USB-C docking adapter that has like your monitor and internet cable, Ethernet,
Hmm.
a bunch of USB
Hmm.
cables, that all of those ports all actually share the same connection to your laptop, and so that's more efficient as well. And so that's kind of the same idea. That's one of the ways that laptops have come down in both size and cost as well, and that you don't have all these redundant ports on your laptop. They can all kind of share the same
Hmm.
interface. And so that's another kind of efficiency. We work closely with the U.S. Department of Energy, and the National Renewable Energy Lab has released many papers along those lines, showing those benefits for like co-locating solar and storage, and then co-locating solar and storage and EV charging to reduce the overall costs of deploying EV charging infrastructure. And then the on at a slightly deeper technical level, and part of our patent portfolio is that we do the power conversion at about 1,000 times higher frequency, and that for many components like transformers, capacitors, and inductors or reactors, their size and amount of material is inversely proportional to frequency. And you can look that up on Wikipedia and really in any textbook. We didn't discover that, but it's well known within the industry. And so by operating at 1,000 times higher frequency, we can actually shrink the bulk of the material by one down to 1/1000th. And
Hmm.
so we're not actually 1/1000th of the size, because we still need things like doors and connectors and whatnot, which is kind of like overhead. But we overall end up being about a tenth of the size or less than the status quo.
Interesting. And then, so is it because of this method that you're able to charge faster? Because I understand from the website that you guys are able to charge faster, correctly? Is that correct?
That's right. So if you think of a Tesla urban charger, that's really just a normal Tesla charger that charges at 1/5 the speed. So they're saying if you're in the city, uh, charging from an urban charger, you have to wait 5 times longer to charge your Tesla, and
Hmm.
that's because of size and power. And so, whenever you're a tenth of the size in the same footprint, you could actually install 10 times more equipment. So you could actually charge 10 times more vehicles, or charge the same number of vehicles in a tenth of the time.
Okay. Got it. That makes sense. And then what about the cost? So you talked about the costs being lower for the product. I'm curious to understand from your perspective, what the reduced costs are of installing these, but also would like to understand the business model that could be working, that how you guys would manage your business model, but also how this will affect organizations installing it, whether that be gas stations or hotels, etc.
Yeah, EVgo, which is one of the largest DC fast charger network operators and owners, they released a study that showed about half of the cost, or an equal amount of cost, was kind of soft costs, which are well known, like in the solar and storage energy. But Rocky Mountain Institute also had a similar study that showed like the development costs is roughly equal to the EV charging equipment
Mm,
costs. And it's all of those soft costs that we're basically eliminating, in that it's a pre-approved, pre-assembled container that can just drop in and install in a few days, which also, by the way, can be relocated in also a few days. And so for a large fleet owner, or as charging
mm,
demands or technology needs change, you actually have that flexibility and kind of optionality over time to redeploy this infrastructure across either your real estate assets or where your customers are. And so that's also a priority for some of our customers. From a business model perspective, today we're closer to a traditional equipment, one-time sell, kind of fixed asset. But over time, we certainly think that charging as a service and infrastructure as a service will play a large role, especially for those operating under capital constraints that might have large operating budgets but not large capital budgets, such as schools or transit authorities, things like that. And so we recognize that financing or doing charging as a service and kind of capturing a larger part of that $2 trillion a year energy market that I
mhm.
referenced from Accenture is another way to grow our revenue and the revenue multiple closer to something like a SaaS company.
Mhm. And then I don't know if you touched on this through that answer, but I'm curious to understand the financing models that you guys offer for your different customers, and if you could also comment on maybe who might be the most common customers, especially initially.
Yeah, most of our customers, and we're under 100 NDAs, but most of our customers have lower capital costs than we do. We have many like large investor-owned utilities that are interested. They happen to be both in a position to benefit from this technology and the revenue growth represented from EV charging and accelerating and streamlining the electrification of transportation. But they also happen to be large fleet owners as well. Those and other large fleet owners, they generally have a low cost of capital, but or lower cost than us. But we are interested in part of the clean tech movement. I'm sure many of your other guest speakers have mentioned it, with the all the funding pouring into clean tech right now. It's like Goldman Sachs and Morgan Stanley, and a lot of the traditional financing groups have opened or announced multi-billion-dollar green tech funds, and that's in addition to the Department of Energy Loan Office, which loaned, I think, Tesla almost $1 billion. And Jigar Shah is always claiming that, EV charging qualifies under DOE loan
Mhm.
office funds. So that is going to help speed up the electrification process in what is, has been traditionally a very capital intense, area of the economy.
Interesting. Okay, got it. Um, I'm kind of curious to understand, broadly speaking, I know this tends to be a large objection for maybe people who are not certain about buying EVs yet, is what what do you think is the estimate in terms of how many how many charging stations across the country we're going to have to achieve to make it really fully functioning network? Obviously, there's the ideal and kind of the bare minimum. Could you maybe just speak to that objection and kind of what you see in terms of the speed here that we can achieve that, and as well as kind of the numbers we might need to look at hypothetically?
That's a great question because there was a study released, I think, by the California Energy Commission that we're also working with, and they found, I think it was 1 in 5 or 20, roughly 20% of the EV adopters in California actually returned the vehicle due to a lack of charging.
Mm,
And you know, to many people, the idea of charging at home just isn't a possibility. That's really only available for the early adopters. And that same Accenture mobility report that, references the $2 trillion a year energy market, uh, it also says that over half of the potential EV buyers actually don't have access. So if you think of like street parking or garage parking in the city, you don't have the access to install your own charging equipment in those kind of
mm,
shared facilities, which happens to be a majority of drivers. And so once you cross that, point, you recognize that fast charging and workplace charging has a much larger role to play. And we are particularly, bullish on DC fast charging, and part of that is due to the constant battery improvements. And our vision of the future is being able to recharge any vehicle, whether it's a semi freight truck, or a small passenger vehicle in just 5 or 10 minutes. And one reason that we're so bullish on that is because of solid state batteries and other battery improvements. But our technology is one of the few that actually allow that like remove that grid capacity problem, which as the charging speed becomes more closer and closer to something like gasoline, refueling in 5 or 10
hmm
minutes, it places a larger and larger demand on the grid and the available real estate. And those are the two problems we in particular solve. Most of the other groups, that have validated that power capacity is a problem, depend solely on batteries. But we see that as more of a transition technology because if you just imagine the customer experience that if you show up to one of these kind of gas station like chargers that depend on a battery, well, if a Tesla came through right in front of you, it's actually going to take you like 4 or 5 hours to charge. So
hmm
how many times are you going to go to that charger if you show up and it says, oh, please wait 3 or 4 hours when you're expecting 15 or 20 minutes? And
hmm
so we are a permanent fast charger upgrade that isn't really dependent on how many vehicles are coming by. And pretty much everyone else in the market is dependent on a battery and solely on a battery to provide a fast charging experience, but they can only do that if a small number of vehicles are coming through to charge.
Okay, interesting. Yeah, that does seem like an interesting dilemma that will have to be addressed there, but that makes sense with your technology and what it can do. Um, Maybe kind of along these lines with deployment of the technology, I'm curious to hear your thoughts on the infrastructure bill and how that might affect, or how it, at least in the immediate future, is going to help kind of advance deployment of these technologies.
Yeah, I mean, obviously, we have a vested interest in seeing more EV charging infrastructure deployed. But if you look at the success in pushing down prices through scale in the solar and stationary energy storage space, and that type of initial spending and support really did push down prices and help speed up the market transition. And as I said before, this isn't just a government mandate. It's actually the lowest total cost already to operate
hmm
delivery in 3 out of 4 U.S. cities. And so with that improvement in productivity, it's actually going to save money for all customers and all of society in general, while at the same time reducing emissions and the other negative externalities related to that, be it flooding or storms or whatnot, other health effects. And so we're big fans of the infrastructure bill, and the only slight change that if we had a line item capability on it, or
Mm-hmm.
more feedback, would be we don't think level 2 AC charging is, I think we all think it's going to be obsolete very soon, because uh, it's especially in terms of public access, at maybe at something like a hotel if you were parking there overnight, but it's a rather limited use case. And so being saying it's going to recharge in something like 12 hours or 15 hours, with something like a Rivian and Lucid coming out that have basically twice the size almost of a Tesla battery. Your chargers actually have to get proportionally faster, or you're taking 2-3
Mm-hmm.
times longer to charge.
Mm-hmm. Yeah, okay, that makes sense. So basically, maybe the specific technical things that are being backed by it. Yeah, I think that's always an interesting dilemma. It's been a pretty common theme on the podcast as people talk about the regulatory market, or regulatory affairs affecting the markets, and it tends to be whoever's in the ear, right? Whoever's helping create that bill. Sometimes maybe not the perfect alignment, but interesting to hear. Um, One thing that is interesting to me, I'd be keen to hear your thoughts on, is you mentioned supply chain issues, and I'm curious about the actual materials involved in your product. Uh, are there any potentially limiting factors or concerns in that supply chain, especially with lots of the things in the world just being sometimes tough to reach? I'd just be keen to hear maybe your broad thoughts, and how it might be affected, as well as kind of down to the nuances for your specific situation.
Yeah, so a big difference between us, and so there are a handful of university programs that have demonstrated similar technology as ours. While they don't have, or that we're aware of, have any patents in the area like we do. They were predominantly focused on kind of prototype or lab only materials from companies like Wolfspeed or Cree, which has developed and is a leader of a new kind of transistor material called silicon carbide. It's actually what's used on the Tesla Model 3 now, and we have Tesla again to thank for paving the way for everyone to follow them. And through that volume and efficiency improvement that they've achieved with companies like Wolfspeed and other silicon carbide manufacturers, that has really helped the supply chain mature. But we're focused on basically the best available materials today, and that's what has allowed us to begin commercializing this technology basically faster than everyone else who was using only those kind of research only samples that have been 10 years off for the last few decades.
Mm,
And so that's an advantage of our system. From the rest of the supply chain, it's able to be manufactured, and a lot of the material is quite similar to something like a solar inverter, which the US and global economies are already pumping out gigawatts worth of infrastructure based on very similar kind of supply chains. And the EV charging market, we think will be able to utilize and
hmm
really get probably a preference to from all of those manufacturers in terms of the EV charging market is a kind of a faster growing market than solar, and a little less competitive. So for those reasons, we're we're excited about being in the EV charging space, and don't foresee any manufacturing constraints
Hmm.
limiting this large rollout.
Hmm. Got it. And just a quick question on that is where, in terms of your guys' process, are kind of at a point where you're reaching mass manufacturing, or is it still kind of in the early stages now that you guys have proven all the technology and the prototypes?
Yeah, we're basically transitioning to the mass manufacturing model, and part of what we're conducting right now is select pilots with Fortune 100 customers, basically the largest fleet owners in the country, and lining up orders and reserving capacity for the next few years as uh, there's a large amount of vehicles and requisite chargers going to be rolled out.
Hmm. Got it. Makes sense. I'm curious to understand. Could you talk a little bit about the process of when you guys decided it was time to fund? What was that look like right now, given so much interest in the climate tech space from VCs and institutional investors? I'm just kind of curious to hear how that process worked. If you could just speak to that.
Yeah, we were fortunate, in terms of timing. It would have been, uh, it would be nice to say, hey, we planned it all this way, but we're actually just lucky in regards to the timing. It was a really oversubscribed round. We still have people inbound, wanting to participate, and uh, we had one big difference from us in terms of most other EV charging companies is that we were profitable last year,
Mhm.
and we had been growing organically off of orders and government projects, and that allowed us to focus on getting the technology right, and then now we're starting to scale it up. But before we had never even tried to raise any money, but growing organically obviously takes longer. And when we saw the market speeding up in terms of the amount of infrastructure that's going to be deployed, we want to maintain our year or two head start in technology. And so that's how it made the decision between that and there being such a high demand for companies like this right now, or like clean tech companies in
Mhm.
general, that it kind of made the decision to raise now easy. And so with this, we'll be able to maintain our multi-year head start, and double our patent portfolio and our units deployed and
Mhm.
headcount and sales and all of that.
Yeah, I think it's obviously a very interesting time, and it does seem like the timing is quite good for you guys. So that's good. Good to see. Obviously, the biggest goal here will be to upscale as quickly as possible, so we can get as much of this deployed to the market. Maybe one last kind of topic or question on this topic generally would be, um, in terms of the. Uh, sorry, I just lost my question. I have to cut this out. Um, I lost my question. Um, Supply chain deployment. I was going to ask. So in terms of talent for installing, I'm curious to understand maybe what kind of upskilling is required for people to install this technology. And I know a lot of people talk about being afraid of people's jobs being taken away from other technologies as things shift. So I'm just kind of curious if you know kind of what's being done to do this. How hard is it for workers in the space to be upskilled?
Yeah, I mean, our idea for the installation in terms of efficiency, that with the same crew, like construction crew, and our friends at Tesla actually have roles called permit managers, And so having a pre-approved, pre-inspected, pre-assembled container also reduces a lot of the permitting and inspection processes. And so, with all of these benefits of our system and, a tenth of the real estate and things like that, you can deploy 10 times more infrastructure basically with the same number of people. And so in that way that we're pushing prices down, we don't really see that as taking a lot of people's jobs or anything like that. But we do try to make the process as easy as possible. But being a U.S. manufacturer, we have and we were on a White House EV charging panel, this week, and we certainly hiring lots of manufacturing people in our U.S. headquartered facilities, and we aim to keep this equipment being built on shore for
Mm-hmm.
the foreseeable future.
Mm-hmm.
And that also puts us in a particularly good position on things like the government infrastructure bill and other kind of Buy America related government spending. And we also have a few projects with the DoD because the Department of Defense also has a strong objective towards lowering emissions and simplifying
Mm-hmm.
their own kind of fuel supply chain issues.
Okay, that makes sense. Yeah, I think that tends to be an elephant in the room, that the government, our defense system does have quite a large footprint. So that's interesting to hear that. I would be curious. One other big thing is here in terms of what I've noticed is that with a lot of these new technologies coming out, there's always tends to be kind of the next issue on the horizon. Are there any specific technology gaps or just, I guess, probably more on the hard tech side of things that are still existing that need to be solved as this rollout comes more and becomes more widely adopted with EV charging?
We're fortunate that interoperability and the testing between manufacturers of both the vehicles and chargers is quite mature already. We're excited about a new standard called the Megawatt charging system that's for freight. We're one of the few companies that can charge 3 or 4 megawatts from a single system, in a single container.
Mhm.
And again, displacing those grid upgrades. I think I mentioned before also to really achieve the 5 to 10 minute kind of gas-like or petrol-like refueling experience, that solid-state batteries have a fairly large role to play, which I think Volkswagen, GM, and Toyota have all made announcements around expecting to deploy solid state batteries in 4 or 5 years from now in production. And so there are companies like Solid Power and QuantumScape and a handful of others that that's our vision of the future. So that would be a gap, but it certainly doesn't, we don't depend on that. It's just we think that would be a preferential customer experience. And that would also allow the vehicle prices even to decrease, because you wouldn't need as large of a battery if you could, recharge in 5 minutes. There wouldn't be much range anxiety in that case.
Yeah, yeah, that makes sense. I mean, I've talked to a lot of people who always complain about the range. For example, I'm from Wisconsin originally, and a lot of people drive all the time there. But a lot of people also don't really tend to drive, at least my parents didn't tend to drive more than an hour or so, pretty frequently they would drive that hour, but it's an hour there, an hour back. So it's 60, 50 to 60 miles one way. So yeah, I think that'll be very interesting once that problem's solved. I think you probably get a lot more a lot more adopters. I'm curious to hear your thoughts on actually this topic of range. So I think you kind of alluded to it with many people, for example, in cities, being in parking garages where their cars are stored, not having access to be able to install this equipment. Could you talk about the differences between urban and rural areas with charging stations and if you feel there's one area or the other that should more quickly adopt it. So if there's any people in government listening, or in local government, to try to help make that adoption happen sooner.
Yeah, there are a lot of incentives around installing fast charging equipment along interstates. And so in rural locations or low income or kind of, in California language, environmental justice communities, they can cite that interstate charging, in those communities, and it can be kind of like a double asset, right? And that
Hmm.
your main usage case might be the interstate user, but in terms of equity, we and spending public funding, if all of the fast chargers are going in very high income areas, that seems somewhat inequitable. And so on the interstate side, that seems like a strong use case that can benefit everyone, and that for that long distance travel. And I think Tesla in particular has said publicly that they're looking to partner with people on their freight charging network. And I think Oregon and Washington recently announced or are planning to implement the same California electric freight internal combustion engine ban. And so there's going to be even more, kind of high power charging infrastructure that's going to be built. And so that equipment, can be, installed to optimize the benefits to everyone as well.
Yeah, interesting. I guess just to kind of wrap things up, then a couple more questions about the, I guess just maybe the future in general, because obviously your technology, as you mentioned at the beginning of the show here, can be used for multiple things. I'm curious if there's other areas of growth that you see as kind of, once this is perfected and really you guys have locked this area down, that you might look to grow to, or that could really use your technologies.
Yeah, many of our customers are large investor-owned utilities, and one reason they're interested in our technology beyond EV charging is that it actually enhances the grid. It expands the power capacity on the grid rather than subtracting from it, and so it can also enhance the reliability of the grid, both for the end user, which would be something more like a microgrid, and then to the grid in general, which would be like a distribution or transmission asset with it, which Accenture estimates to be about $100 billion a year market in terms of grid improvements. So the more traditional use cases would be things like demand response and vehicle to grid, but there are other revenue streams, and in certain markets around the U.S., there's already pricing mechanisms to reward either large fleet owners or asset or energy users for these benefits to the grid. Things like a brownout or other kind of power flow related problems. All kinds of network benefits can be added as part of the same infrastructure rollout, which is part of that multi-function device that we were talking about
Hmm.
before, and that just pushes down prices and improves the reliability both for EV owners, but for non-EV owners and the grid in general as well.
Hmm.
So allowing us to add more solar and wind without having problems with things like harmonics or transmission or distribution line constraints.
Interesting. Okay. Yeah, that makes sense. I think that's been a pretty common theme too, is everybody's discussing the grid capacities, and that's something I do a lot with the recruiting I do is within that space. So it makes sense to me. Maybe just finally, for people who are very interested in the EV charging space, is just the infrastructure side of things here. Maybe young people going into universities right now, are there any specific programs that you're familiar with that are, really good at helping educate people on that side of things, or maybe specific degrees that you find the technical skills will be super applicable, even if there is no particular program created to help create a workforce for these areas?
Yeah, I mean, software in general, managing large networks and all the data that comes from, large number of like customer transactions and things like that, optimizing energy. Then, beyond software, and I'm a little biased because I studied computer science, but and software is eating the world. But after that, you have, we have the most number of electrical engineers, PhDs to entry level, and um, that is quite important because we are a power electronics company, and power electronics is kind of like the best of both worlds between high speed software and like kind of almost like the heavy equipment part of
Hmm.
electrical engineering. And then but yeah, I mean, anyone who loves to learn, there's a lot of opportunities in the clean tech space. And so, why do anything else than when you can wake up, work on a fun problem, and feel better about the impact you're having on the world?
Yeah, that makes a lot of sense. I think what I've found with a lot of younger people I've spoken with is just there's not a lot of knowledge about the different things out there, and I think this could be a critique on the education system, is that people are forced to go into fields or choose fields when they don't really know kind of what's out there, what the problems that are coming down the pipeline or being solved are. So I'd be keen to see in the future, probably have you on again as you guys continue to succeed here. Maybe talk about in the future some of the things you guys are doing in partnership with universities. I know once companies tend to get down the product and the delivery, they tend to do things along that line with working with universities. So would be keen to see how that goes in the future. But any other closing thoughts that you have for us?
No, I mean, it's really important work that you're doing, and getting the message out about clean technology. We're huge fans, and thank you so much for including us.
Yeah, absolutely. We totally appreciate you coming on. Without individuals like yourself that can help us understand it. It really makes it hard for non-technical people to know actually the economic value of why we do climate tech and why these different technologies are actually super good. So thank you so much for joining, and we'll have you again in the future.
Thank you.
Thank you so much for listening to today's episode. I really hope you found it enjoyable and valuable for you. As always, if this technology is something that you think you or your partners are looking to implement, feel free to reach out to them. Obviously, they have a great team there, growing very, very quickly. So I think they could definitely help you. And of course, if you know somebody in the space who might find this technology interesting or helpful, please share this episode with them, or share the website of Resilient Power directly with them, give them a bit of context. And as always, we do appreciate when you share this with your networks. A large part of the reason we started this is because we believe in the importance of mass collaboration across the industry of clean tech. So, in order to help solve the climate change crisis, we really think that these leading technologies need to be shared, and people need to be made aware of them, because there's so many opportunities for implementation already. I just really, really feel strongly that this is important. So, your help there is much appreciated. And of course, another way you can help us out to spread the word is by giving us a review on Apple Podcasts if you listen. And then that helps us to gain recognition and reach within that medium. And then, of course, you can also, if you want to get more involved, consider joining our Slack channel. We've just recently brought on a community manager to help share some interesting things daily, get discussions going. It could also be an interesting way for you to interact with other entrepreneurs, professionals, or in the space. And again, kind of increase that collaboration that we're looking for. And then, if you have not already, it's not too late to finish off the last few days of the Sustainability 30 Challenge that we're doing with the newsletter. We have a few more days left where we send out this little tidbit of kind of an idea on how to live a life a little bit more sustainably. The whole goal there was to help kind of incubate this idea and this mentality of living sustainably. So you can do that. Links in the description to sign up for the newsletter. And then, of course, there on out, we'll be sending out, just continue on the regular schedule of every 27th of the month. We'll send out one newsletter kind of with a deeper topic. So there's that. And then the links for the description is all in the description. The links for everything I've just mentioned is there. Again, big shout out to our sponsor, Next Wave Partners. And if, of course, you or somebody else you know is interested in sponsoring the show, please do reach out. I'm pretty available on most mediums. I'm always checking things, so feel free to reach out there. And then kind of a quick note on next week's episode. It will be with Forbes 30 Under 30 winner John Walsh, the founder and CEO of Endera, which is a commercial EV company doing some pretty incredible things in general. So tune in next Thursday for that. And again, thank you so much for listening to the podcast, and we will see you next time on Clean Techies.